Hi everyone, this is section 1.6 of Integrated 2 KC8. So in section 1.5 we learn how to multiply polynomials together, more specifically binomials where we used a box to multiply to show that visually. Okay, so today we're going to do the same thing, we're going to multiply, but these are special products. You get special, it's not the same thing from before. Right, so from before I can show you here, like number 3, we multiplied two binomials and our answer was a trinomial. We had 3 different terms. That is not going to be the case for these. Okay, so for example, I have x minus 3 and x plus 3. So I'm going to do the same thing that we were doing before. Okay, so I'm going to create my box, 4 squares, and I'm going to put x minus 3 and x plus 3. I'm going to do the same process that I was doing before. So x times x squared, x times negative 3, negative 3x, 3 times x, positive 3x, and 3 times negative 3 is negative 9. Again, just like before, right across from each other, I'm going to add these and look to see what happens. I have a 3x plus a negative 3x, which is actually going to give me a 0x or just 0. I have no more x variable. So this actually becomes x squared minus 9 as my final answer. Okay, so now why does that happen? Okay, this happens because you multiply the same binomial with opposite signs. Okay, that means that your answer is then going to be a binomial. Since you ended up canceling that middle term. Okay, this is always going to happen when your signs are opposite and you have the same number after that. Okay, or the same binomial. The only difference is that sign. Oops. Sorry about that. All right, so let's go ahead and do another example. Okay, so I have x plus 7, x minus 7. Again, I'll do the same process. X plus 7, x minus 7. Multiply, I get x squared plus 7x minus 7x and minus 49. And would you look at that? These are opposite from each other, so they will cancel out and get 0. So my final answer is x squared minus 49. Now these special cases are they actually have a name for them. Okay, they are called, this is called, and I'm going to write it over here, the difference of squares. Okay, it's a difference because they're being subtracted. And they're squares because 9 is a perfect squared and x squared is a perfect square. Now we have talked about perfect squares before, and we are going to talk about them again when we learn how to factor these. Okay, so I want you to pause the video and try number 3 on your own. Okay, so here's my box. X minus 9, x plus 9, and multiply everything out. So I get x squared minus 9x plus 9x minus 81. And again, these will cancel out to give you 0. So my final answer is x squared minus 81. And I'm done. Now, sometimes you're only going to be given one binomial and they tell you to multiply. However, okay, if you notice, they give you one binomial, but they also give you an exponent. Okay? Now, a lot of students, and this is a really, really, really common mistake, they will distribute this and say, well, that's just x squared minus 4 squared, which is equal to x squared minus 16. This is wrong. I want you to write it in your notebook, okay? Because I want you to see why it's wrong. Okay, you have to think about what does squaring something actually mean, right? It's not just using the distributive property when you have more than one term, okay? Squaring something means that you're multiplying the same thing twice, right? You have two of those binomials. So this, you actually need to expand. Okay, this is actually x minus 4 times itself again. So you don't really have one binomial, you have two. Then you can follow the same steps that we were doing before, right? So we can create my box. You have x minus 4 and x minus 4 and multiply. So I get x squared minus 4x minus 4x plus 16. Okay, remember that a negative times a negative will give you a positive. So now I get to combine my like terms which are across from each other. So negative 4 plus negative 4 is negative 8x. Okay, remember that when you are combining like terms, you are now adding or subtracting depending on your signs. You are no longer multiplying. Okay, you already did the multiplication part, and that's how you got your values or your terms inside the box. So my final answer, x squared, which you have in here, minus 8x plus 16 is my final answer. Okay, I'll go ahead and pause and try number 2. So I get x plus 2 and x plus 2. Remember, this means that there are two of them. So you get x squared plus 2x plus 2x plus 4. Combine your like terms, which gives you 4x. So my final answer is x squared plus 4x plus 4. And I'm done. Now, before we move on, we need to have a conversation. And we talked about polynomials and the different types of polynomials that there are, right? There's a monomial, binomial, trinomial, and a general polynomial. But we didn't talk about functions that are not polynomials, okay? So a function, there are 3 things that we're going to focus on that are not polynomials. Okay, a function with a root or a radical. Okay, and if you remember, that's that square root symbol. If you see an equation or a function with this symbol, it is not a function. It is not a polynomial. It's a radical function, but it is not a polynomial. Okay? Also, a function with an absolute value. Okay, and if you remember what that looks like, you had lines, and then there's like a function or an equation in between those. Okay, so if you see an equation with those absolute value lines, it is not a polynomial. It's an absolute value function. And last but not least, a function with a negative exponent. Okay, for example, x to the negative 3rd power. That is not a polynomial. It is a rational function, which we talked about in prior units. Okay, but this is not a polynomial. That's it, guys.